Okay, in this video we're just going to look at a concept which we call angular velocity. So what angular velocity is, well, the name says exactly what it is. We know that velocity, the term velocity that you're usually familiar with is what we'd call a linear velocity. So a linear velocity, try to write this a little better for you. A linear velocity, you can think of that as like your regular velocity that you're used to. That's just equal to distance over time, or the change in distance over change in time. So an angular velocity is a very similar concept, except instead of measuring the change in the distance, you're going to measure the change in the angle. So a angular velocity so it's the change in an angle over the change in time. So this would only apply to a case where something's moving sort of in a circle, or like an angle is changing. Letters we use to denote these two quantities, so usually we'll use V for linear velocity for, I think, obvious reasons, V for velocity. For angular velocity, because we're measuring an angle, we usually use Greek letters for angles. So the letter we use is this one. Looks a little like a W, but it's actually what we call an omega, a lowercase omega. We usually use lowercase letters for angles, lowercase Greek letters for angles. So we use a lowercase omega for angular velocity. So here's an example just to kind of give us an idea of how to work with this quantity of angular velocity. So if you have a car traveling in a circular track, so it's traveling around a circle. The track is 2 kilometers long, so that's the circumference of the circle. Right? So the circumference equals 2 kilometers, and the time is 60 seconds. So we want the angular velocity, so that's omega equals the change in angle, so we use theta for angle, over the change in time. So T for time, you could say the change in the angle over the change in time. Now, one thing it doesn't say in the question is what units to measure the angle in. So we could measure the angle in many different units, right? So we can measure in degrees, radians. We can actually measure in what we call revolutions. So let's say we did it in degrees. This is the less common way and not the way we're going to do it the most, but let's say we did it in degrees. Then omega would be the change in degrees. So how many degrees changed as it went around the track one time? And the answer to that is 360, right? So it went around the track 360 degrees in 60 seconds, or 1 minute. So we could say that the angular velocity, just simplifying this, would be 6 degrees per second. Okay, so it changes 6 degrees every second. If we wanted to do this in radians, then how many radians does it go around the track in one revolution? And the answer, if you remember, one revolution is 2 pi. So 2 pi radians per 60 seconds. So 2 pi divided by 60, that would be, we would reduce to pi over 30, and that would be radians per second. Okay, and then another way to do this, way to measure angles, is with revolutions. So you could say the angle or the angular velocity is equal to how much the angle changes. But here we're going to measure the angle in sort of full revolutions. So it's 1 revolution per 60 seconds. So that would be the angular velocity. So 1 revolution would be 1 over 60 revolutions, or revs, per second. Um, so that's just another way to measure angular velocity. And actually, in revolutions is one where you hear it often. You'll often hear the term RPM, which is revolutions per minute. So we could get this in revolutions per minute just by converting seconds into minutes. But in this case, we did them all in seconds, so we'll do it in seconds. But you could change the unit of time to whatever you want. So that's angular velocity. Let's just compare this to the linear velocity. What is the linear velocity of this car traveling around a circle? So remember, we had this circular track and the car is traveling around it. So the angle is changing, obviously, as it goes around. But the car, sort of its linear velocity at any time, assuming it's going at a constant speed, remember v is equal to the change in distance over the change in time. Well, the time, we were told, is 1 minute. It takes 1 minute to get around the track. And we know that the distance is 2 kilometers, right? The distance is the circumference of the track. So the change in distance would be 2 kilometers over 60 seconds. So that would be 1 over 30 kilometers per second. Now that's not the typical way to explain a car's velocity. Usually you talk about velocity for a car in terms of kilometers per hour. So in order to convert this, so remember we got 1 kilometer over 30 seconds. So the way I usually explain how to convert from seconds to hours is just by multiplying fractions. So remember, we want to convert seconds to hours. Usually people know seconds to minutes first. So there are 60 seconds in 1 minute. So these units will divide out. And then 60 minutes in 1 hour. So these units will divide out. And then you've got 1 times 60 times 60, which is 3,600, divided by 30 times 1 times 1, which is 30. And then the units are kilometers over hours. And just reducing that gives you 120 kilometers per hour. So that's the linear velocity as opposed to the angular velocity.